Now we're going to deal with the questions in workbook related to chapter number 3. We have already done question number 1 and 2 were your homework. You should have done them. And now we're going to do question number 3, okay, on page number 80. This is related to chapter number 13. Statistics, right? Okay, first of all, it simply is telling you to construct a pie chart. So part A and part B are your homework. This is simple. Data is given to you. You need to find the total and follow the steps to make the pie charts. I'm going to do part C as an example for you guys. Okay, part C, first of all, what does part C says? It says a school asked 600 boys to name their favorite sport. The table shows their choices. So the number of boys, their total is already given to us. The total is 600. Data is already given to us in the form of a table, so we don't have to make the table, we don't have to find the total, we just have to find the angle for each of these categories, and then we can just construct the pie chart. Okay, I already did that much. I found the angle for the slices. 70 according to the table. Badminton, 70 boys prefer badminton, right? 70 boys said that badminton is their favorite sport. So 70 is the value and 600 is the total number of boys. So 70 divided by 600 multiplied by 360 is going to give us the angle for badminton. Again, basketball is 90. The value for basketball is 90. So 90 divided by 600. Athletics is 105. So 105 divided by 600 multiplied by 360, and you can just find the values of their angles of slices, right? So once you find all the angles of slices, you can add them all together to check whether they all is the sum of them is equal to 360 or not. If it's not, then you need to verify you need to recheck your calculations. You did something wrong. Then my one, when I add them all together, it's equal to 360. I already confirmed that. So now I'm just going to proceed with constructing the pie chart. First step, you need to make a circle using a compass. Again, how much you're supposed to open the compass is totally your choice. You can open it a lot, making a big circle. You can make it small as well. Doesn't matter. What matters is that your angles should be accurate. The size of the pie chart doesn't matter. What matters is that your angles should be and must be accurate. Okay, I'm gonna open it a lot so that you guys can clearly see the construction. Okay, I made a circle. Now I'm gonna make the center visible, starting by making the line from the center all the way to the, let me just make the center even more visible. Yeah, now it's very much more visible. Starting by making a line from the center to the boundary of the circle. Okay, you start by making a line from the center all the way to the boundary of the circle. Then you take your first angle, 42 degrees. Take the compass, protractor, make 42 degrees. The base is on the, which side? The base is on the that side, so we're gonna have to make 42 degrees. It's gonna be right here, about right here, right? So just without even having to do this, I can just, that's going to be my 42 degrees. Then the second line is now going to be my baseline. I'm going to make 54 degrees. 54 comes right here. I'm going to make 54 degrees. Then 63 degrees. Need to make 63 degrees from here. This is going to be in the center, baseline exactly on top of it, right? So 63, it's going to be right here. 63 degrees. Okay, then we have 123 degrees. 123 degrees. Again, this should be perfectly on top like this, and then 123 degrees. 123, right? So it's going to be right here. 123 degrees. Then my most previous line is this, so I'm going to use this to make the 75 degrees. Do I have to make the 75 degrees? No, because it's the last slice. You don't have to make anything for the last slice. It should be like 78. My one is a bit off, but it's perfectly fine. Doesn't really matter much. My one is 79. It's not perfectly 80, it's not 78 as well, so it's okay if you have an error of 1 degree or 2. It's fine. Let's call this 78 degrees. and then that will be, you have to name the categories. This is, okay, no, my pen is not working. This is tennis. 42 was what? Badminton. This is badminton. 54 was basketball. 63 was athletics, and then soccer. Okay, it's pretty visible from the graph, from the pie chart, that soccer is the most favorite one. It had the largest angle, so the largest size as well. Then tennis is the second most favorite one. This is the pie chart that I have constructed by using the data that was given to me. Okay, you need to make sure you color them properly. All of them should be of different colors. Okay, this was just an example. I wanted to show how to construct the pie charts one more time. Then question number 4. Now in question number 4, we are given a bar graph. Okay, bar graph shows the number of students in each level in a school for the year 2013. Doesn't really matter much, but the number of students and the level. This is section 1, section 2, section 3, section 4. Information is to be represented in a pie chart. Find the angle for the smallest sector and state what the smallest sector represents. We have to take the information from this pie chart, make a table, or don't make a table, but you have to make a pie chart from this piece of information. So what we're going to do, first step is going to be taking the information from the graph, from the bar graph, and we're going to make a table. Second step is going to be finding the total. Third step is going to be finding the angles of sectors, and fourth step is going to be constructing the pie chart. Here I've already done that much. As you can see in the question, we have level and we have number of students. So I make one category of levels, the other one for number of students. Then we have section 1, 2, 3, 4 in levels. So in levels we have section 1, 2, 3, 4, and then I just read the graph. In section 1 we have 30, so I wrote 30 in section 1. In section 2 we have 20. In section 3 we have 10. In section 4 we have 20. So I just wrote all of them down. Okay, so that add all the data together, you will get the total. This is the total angle for one sector. Angle for sector 1 or section 1 is going to be equal to value of section 1, which is 30, divided by total, which is 80. 30 divided by 80 multiplied by 360 is going to give you the angle for section 1. Then you can do the same for angle for section 2, and section 3, and section 4, and construct a pie graph. One more time, we're going to construct a pie graph, pie chart. Okay, messed up here a bit. Yeah, okay, fine. That's it. Okay, this is our center. We're gonna start by making a line from the center. Should use a pencil. To the outer boundary. Line from the center to the outer boundary. Then our first angle is 135 degrees. Take your protractor, place it here. Use the outer scale. It's gonna be 135 degrees. Easily, you can draw that. 135 degrees. Okay, the next one is 90 degrees. Place it here like this. 90 degrees. Okay, so this is our 90 degree angle. Okay, then we have 45 degrees. Degrees, and then again 90. This is 90, so we don't have to make it. You just have to name them now. This is sector 1, this is sector 2, sector 3, and sector 4. You can color them up and your pie chart is complete. It was just that simple. The important thing about this question was to take the information from the bar graph and put it in the form of a table, then making the total, and then using that information to construct a pie chart. So we basically used the bar graph to make a pie chart, which is pretty interesting, right? And that's how we do question number 4. Question number 5 is where things get interesting, right? This is important because we haven't done much examples of line graph, so we're going to learn how to draw line graph properly here, and in question number 6 and 5 as well, right? So these two examples are dedicated to making a line graph and understanding a line graph, right? First of all, table is given to me. I just need to do the same things that I did with a bar graph. here, as you can see. First of all, mostly in line graph, I want you guys to remember this one thing. Whenever you have time, for example, month is a time, is a period of time, right? Seconds is a period of time. We have minutes is a period of time. Hours is a period of time. Years is a period of time. Wherever you have time in these graphs, you have to write the time at the bottom, right? So time should be mostly at the x-axis, while the other quantity is going to be in the y-axis. So I wrote the months down from starting from 1 all the way up to, no, starting from 0 basically. I'm going all the way up to 10. Each of them is equally spaced. I first took the measurements. I took my ruler. I made a line of almost 16 degrees, 16 centimeter, and I divided 16 by 10, so I got 1.6. So I made each of these segments equal to 1.6 centimeters long, right? So that's how I made sure that each of them are equal. Then I took my ruler again, starting from 0 all the way to 10 centimeters, and then I simply made the lines 10, 9.5, 9, 8.5, 8, 7.5. All of this is showing the mass. What is this even about? First of all, understand the question. This shows the mass of a baby from birth all the way up to 10 months. Now I want to point out one piece of information, is that this graph starts from 1 month. It doesn't start from 0 month. So when they say that this table is from birth to 10 months, they are wrong, because it doesn't start from 0 month. If it started from 0 month, then it would have been from birth to 10 months, but it starts from 1 month. So the actual table is about the mass of baby from 1st month to the 10th month, okay? And that's exactly what we're going to do in our line graph as well. Our line graph is going to start from 1, not from 0, okay? So we don't know what the mass of the baby was at birth, okay? Why did I make sure that the start of scale is from 0 all the way up to 10? It's because the mass is starting from 3 and going all the way up to 10, right? So the range is almost from 0 to 10. That's why I made sure that I start my line graph from 0 all the way up to 10. Even though in previous examples I've already showed you that sometimes in line graph we start not from the 0 but from some other number, for example 4, for example 6, whatever is more convenient for us, making sure that the graph is always there, right, inside. But here I started from 0 because the mass was also near to 0, okay? So it's okay for us to start from 0. One more thing that I want to point out is that the most important thing is making sure that the distance, the gap, it remains same, okay? So from 0 to 0.5 I have a 0.5 difference, then again I have a 0.5 difference, I have a 0.5 difference between each and every single one of these numbers, and I made sure that the gap is also the same. Each segment is also the same, as you can see. Now this is going to make sure that my graph is going to be more accurate and more proper. I'm going to take my ruler, I'm going to go on 1, and I'm going to read from the table. What does the table says? Table says 3.7. So from 1 I have to go to 3.7. We have 3.5 here and we have 4 here, so 3.7 is going to be in the middle here, right? So I made this point. This is for 1. Now for the second month, you need to make sure your ruler is straight, not going like this or this. We should be straight. Okay, so in the second month it's where? It's 3.8. It's more than 3.7, but it's not exactly on 4, so we're going to make it right here just to show a little increase, but not too much. It should be below 4. It shouldn't be. My one looks more like 3.9, but it's okay. It doesn't really matter much. It's just, it has to be below 4 and above our previous dot. That's the most important thing. Okay, then we have 4.7 in the third month. In the third month it's 4.7. That's an increase. So 4.7 is around in between these two lines, right? So we're gonna make our third dot here. Then the fourth month is 5.4. 5.4 is very near to 5.5, and this is the line for 5.5, so it's going to be right here. Okay, the next dot for the fifth month is 6.6. We have 6.5 here, so in this line I just have to make the dot a little above 6.5, so that's going to be 6.6. Then for the sixth month we have 8.2. We have 8 here, so we have to go right here in the middle of 8.5 and 8.0, 8 and 8.5. So here is probably going to be 8.2. Then in the 7th month we have 8.3, a bit more than 8.2, so it's going to be right, let's say it's around here, a very small increase you can see. Then we have 9, month in which it had 8.7. Wait, so sorry, in the 8th month it was, oh, the weight decreased a bit. Okay, so it's exactly the same as it was in the 6th month, right? So we're gonna go ahead and make it exactly the same. This should be in alignment. Okay, these two dots should be exactly on the same place. Then in the 9th month it was 8.7, so we're gonna go all the way up to 8.7, which should be around here, below 9 but above, so it's gonna be here. And then in the 10th one, it's gonna be, 10th one is what, 9.4. Okay, the 10th one is 9.4, so a bit lower than 9.5. 9.5 is here, so 9.4 is gonna be here. Okay, you made all the dots, and now you're gonna join them together, making sure you use a ruler. This line, this line, this line, then okay. Well, like this we have. Okay, now we basically completed our line graph. Now we need to analyze the line graph and answer the following questions. Question number 5 part 2 says, between which 2 months was the increase in the mass of the baby the largest? From the graph it's easier to tell that this is the largest increase. See, from 5th month and 6th month, right? So increase in the mass of the baby is the largest between the 5th and the 6th month. It's pretty obvious from the line graph, right? And that's the whole purpose of the line graph, for us to be easily able to tell these things. Okay, question number 5 part 3 says, state the month in which there was a decrease in the mass of the baby. The only month in which there was a decrease was this month. It's a little of a decrease. So the first decrease in the mass of the baby is on 7th month, right? So in the 7th month it decreased a bit, and in the 8th month then it started going up again. This all comes under the 7th month category, right? Because the 7th month continues on and on and on until the 8th one starts, right? So here we see a decrease in this category, right? So that's why it's the 7th month in which we see a decrease. Then the question asks us to find the average mass of the baby from birth to 10 months. Okay, average is equal to sum divided by count. You should remember this formula. This is really important. Average is equal to sum divided by count. So first of all, we have table given to us. We're going to add all the given masses together. That's going to be our total. That's going to be our sum, right? Average is equal to sum divided by count. So sum is going to be the total mass of the baby from birth to the 10th month. Add all the given masses together, you will get 67 kgs. And then average mass of the baby is going to be divided by the count. Count is going to be the number of months. How many months do we have? We have 10 months. So divided by 10. 67 divided by 10 is equal to 6.7 kg. This is the average mass of the baby. That was question number 5. The most important thing to understand here was how to construct the bar graph and the line graph, and the things that you're supposed to be careful about in making a line graph. Okay, making sure that the space is constant and the gap is same, right? And the difference in the numbers is also constant. Then we have question number 6. First of all, state the number of hours in 1000 that the workers in ABC Electronics, ABC Electronics is a company, you could say, right, spent on work from the year 2003 to the 2012. We have a set of how many years? We have a set of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 years we have here, right? So in 10 years we had this many number of hours in which the workers spent working, right? We're going to use this data which is given to us to construct the line graph, and then we're going to answer the following questions using the line graph. Okay, first of all, I've already constructed the graph. How did I construct it? We had how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 segments that I needed to make. I first took, again, 16 centimeters, and I made sure that each of the segment was 1.6 centimeter to make sure that their space remains constant. Then, as you can see here, okay, one more thing is that, as you can see, we have a title here written. You need to make sure that you write the title as well. A graph always needs a title to show what the graph is even about, right? You need to make sure you note down what this is. Like, what is the x-axis about? X-axis is about the years, and the y-axis is about the number of hours for which the workers were working in thousands, okay, in 1,000 hours. What does that mean? That means this is 90,000, this is 100,000, this is 110,000, this is 120,000 hours, okay? Each of them is going to be multiplied by 1000. As you can see, I started the graph here from 90. I didn't started it, okay, basically this is going to be 80. So yeah, I started it from 80 going up to 90, 100, and then 120. The gap is consistent. The gap is of 10. 100 minus 90 is 10. 110 minus 100 is 10. The gap is consistent. It's of 10. I made sure of that. And the space between the segments is also exactly the same. I made sure of that too. I didn't started the graph from 0. I don't have to. This is a line graph, not a bar graph. A bar graph needs to start from 0. A line graph doesn't always have to start from 0. It depends on the data that is given to us. As you can see, the data that is given to us starts from almost 90, goes all the way up to almost 200. 204 goes up right there, right? So yeah, it goes a bit more than 200, but it's around 200. So that's basically our range. We need to take the scale and make sure that it is of that range, right? So I made the scale of that range going all the way from 92. Actually, I should have started 90 here and gone all the way to 210. That would have been better, but it's still fine. Now we're going to take the data and properly put on. One more thing, if you don't understand why we didn't start it from 0, it's because there is no data given to us that is below 90. So that would have been a complete empty space and a waste of my page, right? So that's why we don't have to make all the way from 0, right? Now the data given to us starts from 2004. Sorry, 204. Oh, okay, this is going to be 204. Let's see. Take your rulers, go to 2003, mark the number. Yeah, this is going to be almost 204. This is going to be almost 204. Now we need to mark 172 for 2004. 172 for 2004. 70 here, 75 here. So in between them we need to go. Here, right here. Okay, this was 72. Now next one is 76. 176. Okay, so the fifth one, 2005, is going to be 176. So take our rulers and go all the way up to 76. Then for 2006 it is 182. 182. It's going to be here. 180 and 182 around here, right? Let's just say, yeah, it's here. 182 and then 184. In the year 2007 it's going to be 184. A bit more here, right? So it's more like here. Then we have 184. Okay, 158. In the next year we have 158. Wait a second, it's here. In 2008, right? In 2008 it's 158, yeah. I almost missed one. So it's 158. Goes down to here. We have 60, so a little below 60. It's going to be here. In 2009 it's 98. 2009 it's 98. Goes all the way down here. It's 98. We have 90, 100. This is 100. So it's going to be here, showing 98. Okay, then we have 128. On 2010 we have 128. Should make the graph like this, you know. 128. So in 2010 we go. This is 120. This is 30. So a little below 30. It's going to be 128 right here. Then 11 is going to be 2011 is 172. 172. This line is 170. This line is 170, so a bit more than that, 72. Then it goes all the way up to 200. We've completed our dots. We just now need to connect them. First, we have a decrease, then a small increase, another small increase, and a very, very small increase, but at least it's not a decrease. Then we have a decrease. Said too soon. Okay, then we have a very steep decrease. Sharp decrease here. Goes up. then another up, then another up. Okay, this is our line graph. According to the line graph, now we're going to answer the questions. Between which 2 months was the increase in the mass? Oh, no, this one, not this one. Okay, state the year in which there was a decrease in the number of hours the workers spent on work. So, as you can see, all the years we need to point out. This year, first of all, in which year there was a decrease? So, in 2004, first of all, as you can see, this is a decrease from 3 to 4, it's a decrease. That's why 2004 has a decrease, then increase. Then we have another decrease in 2008 and another decrease in 2008 and another decrease in 2009. These are the three decreases that we can see in the line graph. Okay, this decrease, and this decrease. We have 3 decreases in the line graph, 1, 2 and 3. That's why 3 years we have in which you can see a decrease. Okay, then we have state the years in which there was an increase in the number of hours that the workers spent on work. As you can see, there are a lot of them. First of all, 2005, then 2006, then 2007, then 2010 goes all the way right up. 2010 is up, then 2011 is up, and 2012 is also up. So you see an increase in all of these years. Basically, in every year where you don't see a decrease, you see an increase. So that we can already understand all of this information from the graph. Then state the years in which the increase in the number of hours spent on work was the largest and the increase was the least. They're not talking about decrease, they're talking about the least increase and the most increase. As you can see, here we have the most increase. So the largest increase was in 2011. This is a very steep, very large increase. You can see here, it goes up long and vertically. So this is a large increase. And then the least increase you can see is probably here. So this, look, only have 1 point increase here, 0.1 increase here. That's why the least increase is in 2007. Okay, but it was still an increase. It was not a decrease, it was an increase, right? So that's why it's the least increase. Okay, anyways, we have in some years the number of working hours for the workers spent on work was about 172,000 hours. What are the years? Okay, basically it's asking us in what specific years the number of working hours was more than 172,000. You have to take your ruler for this question, okay, and place it on 172. Place it on 172. It's right here. 172 is right here. Okay, so we have one year that is exactly on 172, another year that is exactly on 172. We don't want them. We are not going to count them because the question asks us for years that are more than 172. So we're not going to talk about that are exactly on it. We want more than it. We have 1 year, 2 year, 3 year, 4 year, and 5 years. Right? So 1, 2, 3, 4, 5. Write the name of those 5 years that are more than 172. Okay? Again, you don't need to talk about the years that are exactly on 172. The question is asking us for more than 172. Okay? Basically, simply we just had to make a line graph and interpret information from the line graph. Okay? That's what the question was about. As we're done with question 6, we're going to go towards question number 8 because we already gave question number 7 as a homework. So question number 8 is going to be our question here we're going to do. Okay? We have a bar graph given to us in question number 8. We have to analyze the bar graph. Okay? Let me just take it properly here. Okay, analyze question number 8. Let me just zoom in a little bit here for now so we can analyze it. Okay, this is question number 8. Each student of whatever was asked individually how many coins they had in their pocket. The bar chart illustrates the result of this survey. So we have number of students and we have number of coins. These are the number of coins. So 6 students had no coins at all. 6 students had no coins. Then 7 students had 1 coin. 10 students had 2 coins. 8 students had 3 coins. 4 students had 4 coins. 3 students had 5 coins. And 3 students had 6 coins with them. Okay? That's how you're going to read this graph. Each one of this bar is telling you about the number of students and the number of coins with each student. Okay? So 6 students we have here, 7 students we have here, 10 students we have here, 8 students we have here, 4 students we have here, 3 and 3 students we have here. And 6 students have no coins, 7 have 1, and you can just continue to read all like that, right? The question it's asking us is that we need to find the number of students in the class. As I said, each bar is representing a specific number of students. we have categorized the students on the basis of the amount of coin they have, right? So 6 students from here, 7 students from here, 10 students from here. You're going to add all the students that are represented by each one of the graphs, and you're going to get the total number of students. How can you do that? Like, so the number of students in the class is going to be equal to 6 plus 7 plus 10. Let's just zoom out now. Wait a second. Okay, as you can see in the graph, number of students in the class is going to be 6 from this bar, 7 from this bar, 10 from here, 8, then 4 plus 3 plus 3. So you're going to add all of them together. You're going to get the total number of students in the class. This is the total number of students in the class. Then the second question asks us the number of coins that the most student has. It's simple. You can just take a look at the largest bar. It's this one, and that's with 2. So the most of the students in the class had 2 coins. Most of the students in the class had 2 coins. Almost 10 students in the class had 2 coins, right? You can see in the graph we have 10 students. Take a look at this. We have the largest bar and 10 students who have 2 coins with them, right? Okay, then the question is asking us the average number of coins. This is where it gets interesting. We have to find the average number of coins. We know what average is equal to. Average is sum divided by count. Sum is going to be what? Sum is going to be the total number of coins. Now how are we going to find that? Take a look at the bar, right? We have 6 students who have 0 coins. We have 7 students who have 1 coins. So we get 7 coins from here. We have 10 students who have 2 coins. Each one of them has 2 coins, right? So 10 multiplied by 2. We have total 20 coins in this bar. How many coins do we have in this bar? We have 8 multiplied by 3. 8 students that have 3 coins. Each of them has 3 coins. So 8 multiplied by 3 is 24. And then we have 4 students who have 4 coins. So in total we have 16 coins here. We have how much? 3 multiplied by 5, which is 15 coins. And then 3 multiplied by 6, which is 18 coins. So each bar has a specific number of coins in them. We're going to add them all together. So I simply did multiplication first, and then I added all of them together, which is going to be 100. So the total number of coins is going to be 100. Okay, that's the total number of coins. That's the sum. We need to know the count. What is the count? Count is the number of students. How many students do we have? 41. So 100 divided by 41. 100 divided by 41. That's going to be our average, which is 2.44. This is the average number of coins that each student has in this class. Okay, each student has almost on average 2.44 coins. This is just an average. Some has more, some has none. So this is just an average, middle number you can say. Okay, in question number 8 part A4, they're asking us to find the number of students having 4 or more coins as a percentage of the number of students in total, right? So first of all, we have to find the number of students that have 4 or more coins. These bars, they represent the number of students that have less than 4 coins. So we're not going to look at these 4 bars, we're going to look at these 3 bars. Okay, number of students that have 4 coins is how much? 4. So 4 plus 3 plus 3, because 5 and 6 is also more than 4, right? So 4 plus 3 plus 3, that's the number of students that have 4 or more coins with them. 4 plus 3 plus 3 is 10. 10 students have 4 or more coins with them, and the total students are 41. So 10 divided by 41 multiplied by 100, it's going to give us the percentage of students that have 4 or more coins in the entire class. Then it's asking us to, okay, if this question, look at this, it says if the information is illustrated on a pie chart with 5 sectors. Now look at this. It's important for you to understand what 5 sector means. 5 sector means 5 slices. In the pie chart, we are going to have 5 slices. But here in the bar graph, we have how many bars? 1, 2, 3, 4, 5, 6, 7. We have 7 bars and only 5 sectors. And I told you, when we're converting a bar graph into a pie chart, we're going to take each bar as a different slice, right? But here, that's not the case. They're asking us to make a pie chart with only 5 sectors. So what are we going to do? We're going to have to merge some of the bars. Which bars are we going to merge? That information is given here. Find the angle for each sector. Okay, we will do that. Where one of the sectors represents students having 4 or more coins. Okay, so each of these bars is going to come as one slice, but these 3 bars, they're going to be taken as one single one. Why? Because it's 4 and more coins. So 4 and more than 4 is going to be 1. We're going to take them all in one slice. This is a different slice, this is a different slice, this is a different slice. So 1, 2, 3, 4 and 5. we'll get 5 sectors complete then. One sector is going to represent, or one slice is going to represent students who have 0 coins, then the other one is going to represent students who have 1 coin with them, the other one is going to represent the students who have 2 coins with them, the other one is going to represent the students who have 3 coins with them, and the last one is going to represent the students who have 4 or more coins with them. Okay, so we're going to find the angle for each one of them. The number of students that have 0 coins is 6. So 6 divided by the total number of students multiplied by 360, you can find the value. Okay, the table, you can just basically take the information from the graph, right? The students who have 1 coin is 7, so 7 divided by total, then 10 divided by total multiplied by 360, then 8 divided by total multiplied by 360, and you can find the angle for each of the slice all the way up to 3 coins. After that, you're going to take the angle representing students having 4 or more coins. So we're going to take students like that, right? We have 4 students from here, 3 students from here, 3 students from here. So 4 plus 3 plus 3 divided by the total number of the class multiplied by 360. So 10 multiplied by 41 multiplied by 360. That's going to give us the angle. And these are all the angles that we need. Again, the question is not telling us to draw the pie chart. It is just saying that if the information is illustrated on a pie chart. It's not telling us to draw a pie chart. So we're not going to bother making a pie chart. We're just going to find the angles for each sector. Then question number 9. It looks difficult as it has a lot of parts, but this is really simple and easy. You just have to understand the graph properly. One thing that I really want you to understand is that this symbol here. Let's focus on the bar here a little bit. You can see here they made this sign. What does this mean? As I have already told you, bar graphs will always start from 0, unlike line graphs. But since all of the space in between 0 and 30 was irrelevant, was useless to us, because just take a look at this. If this part doesn't even exist, then all the bars are going to be the same. That goes the same for every space in between 30 and 0, right? So that's a waste of space. We don't want to waste our space. We want the graph to be compact. That's why we just said that it's going to continue from 0 all the way to 30, just like it's going to continue from 30 all the way up to 55. Okay, so the scale is going to remain the same, and the bars don't show anything important. That's why we're going to skip them there. The scale is going to start here, then 30, 35, 40, 45. The gap is consistent. Okay, the same is the case with 0 and 30. The gap is going to be consistent, but that part is skipped here. Okay, from 30 to 35, 40 to 40. Okay, and then how many segments do we have? We have 1, 2, 3, 4, and 5. We have 5 segments. So 5 divided by 5, 1. So each one of the segment is representing one value. So 35, then 36, then 37, then 38, and 39, and then 40, 41, 42. Each one of them is properly into a single number. Okay. Now analyze the graph. What is this graph even about? It's about the mass weight for an year. Okay. Starting from January, going all the way to December. This is his weight. It started from 46, goes all the way to 40. What is this? Wait a second. It's more than 50, right? So it's 52, 53. Yeah, it goes all the way up to 53 then. Yeah. No, 51, 52. Yeah, it goes all the way up to 52 with the last. In December, he had 52. Oh, you can read the graph, right? Okay, now just read the graph and answer the questions. State the month in which Mars had a weight of 46.5 kgs. 46.5 kgs. Okay, we have to go around and look at the bar properly. Now, if you look at the bar, we don't have any 46.5. We have a 46 and we have a 47, but we don't have any 46.5. And the rest of the weight is always above 46 and 47, right? So we're just going to take this as our answer. We're going to say February was the month in which, we just write the question, then the part, and then the answer is to part number 1. It's going to say February. February is the month in which he had 46.5. So we're going to zoom out now a little bit. Okay, as you can see here, now 49 kg. Look around, you can see that in June he had only one less than 50, which was 49. So in June he had 49 kg weight. Okay, then you can take a look at 50.5. Okay, August, it's what? In August he had 50, right? The weight here in August is 50, but that's the most closest to 50.5. So we're just going to say that in August his weight was 50.5, right? But the point is that we're not reading accurately here. Our readings are not perfect. We cannot say that where exactly does these readings lies, right? I'm telling you about 46 or 47. I'm telling you about 50. I'm telling you about 56. But the bar doesn't continue all the way in proper ways. That means bar graph is not a proper way of representing changes in weight. Okay, this is just a hint I want you guys to understand, that bar graph is just not a proper way of representing changes in weight. What would be the proper way of representing mass weight for years? A more proper and a better way would be to show a line graph. As we have already done this before in the previous questions, line graph is better for showing change and estimating values, right? Line graph is just better than bar graph. Bar graph is for comparison. We're not here for comparison. We're here to show the increase or decrease. Okay, and question number 9, part B. In which month was he the heaviest? As you can see here, the largest value that you see is in November. So he was the heaviest in November. And estimate the value of mass, his weight in that month. Okay, in November, his value is going to be, go all the way here. It's 1 less than 55, so it's going to be 54 kgs. As you can see, he is the heaviest in the month of November, and his weight is about 54 kgs. Okay, then state the month in which his weight were the same. Okay, so first of all, we have two options here like that, right? In the months in which his weights were the same is March and April, and May, October and December. As you can see, I can show you using a ruler that March and April are exactly on the same level. That's why they're exactly the same. His mass was exactly the same in March and April, right? And then you can put it here. See, this bar, and this bar, they're exactly on the same level. This is May, then we have October, and then we have December. They have the same values. Okay, so we have 2 months that are similar and then 3 months that have the same weight. Okay, question number 9, part D. It states that state the range of value for his weight of the year. Now, just one thing you need to understand here is that range is equal to the largest value minus the smallest value. The largest weight he had was 54 kgs. The smallest weight he had was 56 kgs. So smallest, you just have to subtract them from the largest. You will get 8 kgs. That's the range of his weight. It's just that simple. All the things that we're doing here is basically getting the information out from a line graph. Okay, it's nothing complicated. We're just extracting information from line graph and bar graph and pie charts. And that's what the whole chapter is about. Okay, question number 9, part E says there are two instances in which Mars lost his weight. He lost weight greatly when he was sick, and he found out that he was putting on weight, so he started to control his diet. In which month he started controlling his diet? Okay, so as you can see from the graph, we see a decrease here and we see a decrease here. But where do we see a greater decrease? In this month. Yes, in the month of May going to June, right? In the month of May, we see a greater decrease. This decrease is because of sick, because in the question it says greatly. Okay, it's not greatly for the diet, it's greatly for sickness. So the greater decrease that we're going to see is going to be because of the sickness. So in which month he was sick? In the month of May he was sick. And you can see here that from November to December, going from November to December, he decreased his weight. So in the month of November, basically he started controlling his diet. That's why it decreased in December. So the answer is going to be, he lost his weight greatly in May, therefore he was sick in May. And on the 1st December, he lost his weight slightly after his weight increased for the past 5 months. Therefore, he is controlling his diet in November. We see the decrease in December, yes, but that decrease happened in the previous month, right? So that's why in November, he lost his weight. That was question number 8, part E. Now part F. In a particular month, P, his weight exceeded 53 kg. What is that month? Just take a look at this. We have 50, then we have 51, 52, and 53. On 53, we have a few options, right? But the only month that exceeds 53, okay, wait a second, now you can see clearly. We have 50, 51, 52, and 53. Goes all the way here. So the only month that is exceeding 53 is the month of November, right? So the only month in which his mass exceeded 53 was November. So the answer is going to be simply just November. You don't have to overcomplicate things. Just write November as the answer. Okay, now question number G, which I think is the most important question. Question number 9, part G, which I think is the most important part of this question. It says the information is to be illustrated on a line graph. We're now going to make a line graph by using this bar graph. Okay, we are not going to extract the information and then make a table and then make a bar graph. No, I'm just going to show you how to make a bar graph here using this table and you're going to do the same. You have to just do it in the book. You don't have to do it in the notebook, okay? So let's just zoom in a bit. I'm going to show you now how to turn a bar graph into a line graph. Okay, first of all, you need to make points in the middle of each bar. This is the bar, I'm going to make a point in the middle. This is the bar, I'm going to make a point in the middle. Exactly on top of the bar and on the top line of the bar and in the middle of that line, okay? You just have to make the dots. That's it. Make precise dots and then use a scale to join the dots properly. And increase, stays the same, and increase, decrease, a bit of an increase, yes, a smaller increase, goes up, and then again up, then goes down a bit. This is how you construct a line graph using a bar graph, okay? It's just that simple. You don't have to overcomplicate things, but now that makes things so much better. It's so much easier to understand now that in the month of May, let's just, for example, May continues from here and goes all the way up to June. This is the first day of June and this is the first day of May. So this whole thing comes under May category, right? So this is the month of May. We can see that his mass is decreasing in the whole month, and in the start of June, then it starts rising back up again. In this month of June, it starts rising. So his mass is decreasing in May, his mass is increasing in June. Okay, we can analyze much more information using a line graph now. Okay, then it asks us which form of representation, bar graph or line graph, is more suitable to represent and interpret the above data. Again, this was wrong, this was sad, this was bad, because you can see already from here 6.5. We didn't have that in the entire graph, but once you make the lines, then you can make an estimate. For example, this is 5. Wait a second, where do we have 46? Yeah, this is 40. This is 45. This is 46, and this is 47. So in which month can you estimate 46.5? It's basically here, right? So in a line graph, we can properly assume that, yeah, in January we observed his weight to be 46.5. When I was answering this question through line graph, I said what, February, but that could be wrong according to the line graph. So you need to make sure that you're using the proper graph. It's fine for you to say February, it's fine if you say January as well, but I just wanted to pinpoint out this issue, that which one of these is better. So you're just going to simply say that line graph is more suitable to represent and interpret the above data, as we can observe the trend of his weight over the months easily. Okay, remember the purpose of each graph. Line graph is for seeing the changes that happen over time, right? The trend, while the bar graph is for comparison between two things, which is not what we really want here. So that's question number 9. Now question number 10, again with question just like question number 9 has a lot of parts, we're going to skip it. Question number 11, pie chart shows the result of a survey conducted on the vehicles at a traffic junction. Okay, this is the pie chart that is given to you. 2x is the number of taxis, 5x is the number of other things, whatever those are, and 52 degrees is buses. Okay, so what are we going to do? Sum of all of them is going to be equal to 360. We can easily find the value of x. Just use this formula, add all of them together. It's going to be equal to 360. X is 5x plus 2x is 7x, minus 2x on both sides. Then you can get 7x is equal to 308 degrees, and then divide 7 on both sides, you'll get a value of x. X is equal to 44. Okay, that's the value of x. Since taxis is 2x, so instead of writing 2x, I can simply say 88, because 2 multiplied by 44 is 88, right? So 88 degrees is equal to 66. Taxis is equal to 66. This is given to us in the second part of this question. If the number of taxis was 66, calculate the total number of vehicles included in the survey. Okay, it's pretty easy. Just taxi is equal to 2x and also is equal to 66. So we can say 88 degrees represent 66 vehicles. Now you can, in simple words, you can say 88 degrees is equal to 66 vehicles. Now divide 88 on both sides, you will get what 1 degree is equal to. 1 degree is equal to 66 divided by 88 vehicles, and 1 degree is equal to 7.75 vehicles. Okay, a single degree is equal to 0.75 vehicles. So how much a complete circle, which is 360 degrees, is going to be equal to? So multiply 360 here on this side and multiply 360 over here on this side. You will get 0.75 multiplied by 360, which is 270. So in 360 degrees in a complete circle, you will have 270 vehicles. It is just that simple. Okay, first you find the value for one number of vehicles for 1 degrees and just multiply that by 360 to find the number of vehicles for 360 degrees. Okay, so the total number of vehicles is going to be 270. Question number 11 was just that simple. Okay, there is nothing more complicated about question number 11. Question number 12, again we have a line graph, and it says, let's start by understanding what the line graph says. Okay, we're gonna zoom in here on the graph. First of all, the line graph shows the temperature in a classroom recorded every morning for 10 consecutive days. Okay, starting from Monday all the way up to the next week's Friday. Okay, we have Monday, Tuesday, Wednesday, Thursday, Friday. Saturday and Sundays are skipped because those are weekends, and this is a classroom that we're talking about. That's why Saturdays and Sundays are skipped. And again, we have Monday, Tuesday, Wednesday, Thursday, and Friday. Doesn't really matter. These are the days, and they're total 10. Okay, 10 consecutive days. Then again, you can see the symbol here. Let me highlight it for you guys. It starts all the way from 0, but since there's nothing below 24, the graph will be completely empty. That's why they skipped that part and started directly from 24. It's okay, you don't even have to make this up. You just can start from 24, 23 or 24, you can say then. Then you need to make sure that the gap is consistent. From 24 we have 25, 26, 27, 28, 29 and 30, 31. Okay, we have how many segments? 1, 2, 3, 4. So 1, 2, 3, 4 and 5 segments. So 1 divided by 5 is going to be equal to 0.2. So each of these lines is going to be of 0.2 value for 24.2, 24.4, 24.6, 24.8 and then 25, 25.2, 25.4 and so on and so forth. Okay, it's going to go like that. Just a basic understanding I want to bring here, right? Okay, in one of the 10 days it rained throughout the day. State the day in which it rained the whole day. Estimate the temperature of the classroom on that morning. In simple words, it's common knowledge, it's common sense that if it rained the entire day, whenever it rains, it's more colder than it is on usual days, right? For example, it's summer days, they're hot, and suddenly a rain comes, the temperature goes down, drastically goes down, so that you can actually feel it, right? Which of these days in this chart, in this graph, has the lowest temperature? That's going to be the day in which we had rained throughout the day. Okay, the rain was throughout the day, and you can just read the temperature of that day. So basically, you can see that if it rained throughout the whole day, the temperature should be the lowest among the 10 days, which is on the Monday of the first week. You have to make sure you clearly specify which Monday you're talking about. Monday of the first week or Monday of the second week. So you're talking about the Monday of the first week. Okay, it is when it rained the entire day, and the temperature for it was about 24 degrees Celsius. Okay, then we have on which day was the temperature highest. As you can see in the graph, this is the highest, right? And it's on what? It's on the Friday of the first week. So on which day it was the highest? It was on Friday of the first week. Estimate the temperature in the classroom of that day. It's 31, as you can see in the graph. It's 31 degrees Celsius, right? So you can write it simply like this. On Friday of the first week, the temperature was the highest, which was about 31 degrees Celsius. It's just that simple. Then part 3 of question number 12. On which day was the temperature below? On which days, not just a day, on which days the temperature was below 29 degrees Celsius? So you're going to take your ruler, you're going to place it on 29 degrees Celsius, and you're going to see the numbers that are, see the days that are below it. As you can see, a few days have temperature exactly 29. So you're not going to count them because they are not below 29. We need to talk about the days that are below 29. We have this day, we have this day, we have this day, and we have this day. These days are below 29, so we're only going to consider them, not these 3 days, okay? These 3 days are exactly on 29, not below, okay? We need to make sure that we talk about below 29. So the days when temperature is below 29 is in the first week we have Monday, Tuesday and Wednesday, and the second week we have Friday, as you can see here, Friday, right? So the temperature is below 29. And the rest of the cases, it is either 29 or above 29. So we're not talking about them, right? Then we have another question which says, express the number of days in which the temperature of the class was above 28 degrees Celsius as a percentage of the total number of days. Okay, So first we need to find the number of days in which the temperature was in the classroom was above 28, and then we need to find the total number of days, which is, we already know that, which is 10, right? As it is mentioned in the question, it's 10 consecutive days. So we're gonna find the number of days in which the temperature is above 28 degrees Celsius, divided by 10 and multiplied by 100. Okay, as you can see here, I'm gonna place the ruler again. We're not gonna count this because it is exactly 28. It is not above 28. Okay, we're gonna count not this one as well because this is exactly 28, not above 28. We're gonna count all the other ones. 1, 2, 3, 4, 5, 6. We have 6 days in which the temperature is above 28 degrees Celsius. So what are we gonna do? We're gonna say the number of days in which the temperature was above 28 degrees Celsius is 6, and the total days are 10. So 6 divided by 10 multiplied by 100 is going to be 60%. So 60% is the number of days in which the temperature was above 28 degrees Celsius. Okay, now they're asking us to suggest a reason for the sudden increase in temperature in the classroom from Monday to Tuesday. They're talking about this Monday to Tuesday, right? This Monday to Tuesday. As you can see, there's a sudden increase in temperature. Now we already know that it rained throughout the day on Monday, right? On Monday we had the rain entire day, but on Tuesday that's not the case anymore. The rain's gone. The rain is gone. So a very good reason for this sudden change in temperature is because change in weather. The rain was on Monday, there is no rain on Tuesday. That's why we had a change in weather, and that's why we have an increase in temperature. Whenever it rains, the temperature goes down a lot compared to what it usually is, and whenever it's not raining, no clouds, so the temperature goes up. That's what's the difference between Monday and Tuesday is. We can see that from the graph. Just keeping things simple, okay? Our purpose is to understand the graph, and that's what we did. Okay, we're gonna zoom out a bit here. Yes, we have question number 13 now. Starting by understanding the question. The line graph shows, which line graph are they talking about? On the next page, we have a line graph here, okay? This is for question number 13. This is for question number 13. They're saying that the line graph shows that the sale of packets of a certain brand of soap powder in the mini market from 2008 to 2012, okay? This line graph is the data. Then they're asking us, when did the sale first exceed 50,000 mark? Just by looking at this, you can tell. This is 20. What 20? 20,000, because this number of packets is in thousand, right? So 20,000, 40,000, 50,000, 60,000, 80,000, and 100,000, right? So you can see that from 2008 to 2009, it stayed 40,000. Then from 2009 to 2010, it increased and passed 50,000 mark, right around here. It passed, it crossed, it exceeded the 50,000 mark, just like the question is asking us, right? So when did that happen? That happened between 2009 and 2010. Basically a part of 2010, right? Because 2008 continues all the way up to here. 2009 continues all the way from 2009 all the way up to 2010. So this section comes under 2009. And this section comes under 2010. This comes under 2011. And this comes under 2012, right? So this event happened in 2009 basically, right? When it exceeded the mark of 50,000. So as you can say, the sale first exceeded the 50,000 mark in year 2009, which is basically in between, very specifically you can say in between 2009 and 2010. This happened in between 2009 and 2010 because 2010 is 60,000 and 2009 is 40,000. Okay. Then question is asking us, in which year was the sale exactly 100,000? As you can see in the graph, 100,000 we have 2012. So in 2012, the sale was exactly 100,000. It's just that simple. Then we have, between which 2 years were the sale in the soap powder the greatest? Now they're asking us, when was the increase the greatest? As you can see, we have the most steep increase here. Most vertical and most larger line of increase here. This is also an increase, but it's not as much as this one is. This is also an increase, but it's not as long and much as this one is, right? So the largest increase apparently from the graph is from 2011 to 2012, in between these 2 years. You can just simply say between 2011 and 2012, the sales were the greatest. It is just like that. Then find, we have to question number 13, part 4. Use the data from the line graph to construct a table showing sales from 2008 to 2012. Simply, you just need to construct a table. Here's the table. You write years on top, you write the number of packets in thousands. First one, you can read it from the graph. In 2008, it was 40,000. It was 40 in thousands, right? So I just wrote 40,000. In 2009, again, it was 40, so 40,000. 2010, it was 60, so I wrote 60. 2011, in 2011, it was right in the middle of 70 and 60. So that's, 80 and 60. So that is 70,000. And in 2012, it was right up here, 100,000. That was the table. This is just like that. Then they're asking us, what is the percentage increase in the sales from 2010? This is going to be our initial, and final is going to be 2012. I already told you, percentage increase is equal to initial, final minus initial divided by initial multiplied by 100. Okay, final is what? Final is 2012, which is 100,000. So you're going to write 100,000 minus initial is what? Initial is 60,000. So minus 60,000 divided by again initial, which is 60,000, is multiplied by 100. Okay, so you're going to do subtraction first. You're going to get 40,000 divided by 60,000 multiplied by 100. Cancel out the zeros. It's basically 4 divided by 6 multiplied by 100. 4 divided by 6 multiplied by 100. You do that and you will get the value, which is 66.66%. That is the percentage increase in the number of packets of the soap powder. And that was question number 13. It wasn't any more difficult than that. Again, I told you, we've already understood the basic concepts. We're just applying them over and over again. Question number 14 now, which is much more easier than all the other questions we've done. Okay, just read the question and try to understand it, right? The following advertisement, this advertisement, was put up by a coffee chain claiming that its sales has increased by 300% from year 2010 to year 2012. This is year 2010 and this is year 2012. Explain briefly whether this advertisement is misleading or not. Like, just take a look at it. Do you see a graph? No. Do you see any data here? Do you see a bar graph? No. Do you see a line graph? No. Do you see a pie chart? No. Do you see any data given to us? No. We basically just have years written. That's it. And a cup size that increased. There is nothing else given to us here. So this is absolutely wrong. And yes, the advertisement is misleading. The increase in the size of the diagram is not a proper way of representing the increase in sales, and we cannot tell if the increase is 300% or not. This isn't a proper way of representing the increase in sales, and we definitely can't tell by any means that this represents 300% increase. So this is definitely not the right way for them to advertise a 300% increase in their sales. If they want to show an increase in their sales of 300%, they should give us the data properly, that these were the sales in 2010 and these were the sales in 2011 and these were the sales in 2012, and then we can draw the bar graph or line graph and show that the increase happened and properly be able to show how much the increase was then, right? So this is just like that. This is the simple answer for question number 14. It's not more complicated than that. Okay, question number 15. A bakery reported that the sales of its signature bread have doubled from year 2010 to year 2012. They put up a chart that shows the sales of the bread in 2010 and in 2012. They just made a circle. There is no other slices. There are no sectors here or sections here. There's just a radius and a radius here as well. And a name here, the sales in 2010 and the sales in 2012. It's completely incomplete. This is not a proper way. Again, they're just increasing the size. That doesn't mean that it shows a proper, it's not a proper way of representing the increase in sales. Again, just like in question number 14, this is not the proper way of representing data here. Yeah, sure, from 2 centimeter, it went up to 4 centimeter, the radius doubled, but that doesn't mean that the sales got doubled, and it's not a proper way of representing the increase, right? So what do you think? Do you think this chart is a good comparison for the sales? Simply say, no, it is not. Then you're going to explain your answer why it is not, and then explain how you can improve this chart. So we're going to say the actual figure of the sales are not given. I mean, the data is basically missing. We don't have any data here. Therefore, it is not conclusive from this diagram that the sales have doubled. So this diagram is completely wrong. This advertisement, this report that they have made is completely wrong. The data is missing. There is nothing that we can analyze and interpret from this image. Okay, how can we improve this? We can improve the chart by using a bar graph, which is used to compare the sales from 2010 to 2012. Again, they want to show the increase, or they want to show the comparison, a good comparison, right? So since the good comparison is mentioned, and you know that for comparison it is better for us to use a bar graph, that's why I said that we can improve this chart by using a bar graph instead of just some increased size image. Okay, so this is just simple answer for question number 15. It's not any more complicated than that. You don't have to solve anything. You just have to understand. We're going to skip question number 16, going to question number 17. Okay. In question number 17, now this is where it gets interesting a bit. Question number 70 says we have 120 students that were surveyed. This is the total number of students, as you can see here as well. This is the total number of students that were surveyed to find out which of the four mode of transportation, by public transport, by car, by foot, or by others, the students used to travel to the school daily. Now, as you can see in this table, we have missing values. How can we find the missing values? We first need to know that. Okay, we're going to first find the missing values. Take a look at this. First, let's try to read this table. Public transport and male. This is the number of males that use public transport. This is the number of males that use car. This is the number of males that used to walk to school. And this is the number of males that use other means of transportation. For example, they use roller skates, they use bikes, they use cycles or something like that. Or they maybe crawl to school or whatnot, maybe fly. But this is others, okay? And then this is the total number of males. This is the total number of males, okay? Then we have females which have missing public transport here. But this is the total number of females that come through car, that come to school using a car, because they're talking about students, right? Yeah, to school, traveling to school. Then walking is also missing, others is also missing, total is also missing. Here the total is also missing, cars is given, walk is given. What does this mean? This means the total number of students that use car. This is the total number of students that use car. This is the total number of students that come here by walking. This is the total number of students that come to school by other means. And this is the total number of students itself. Okay? And this is going to be the total number of students that come through public transport. Just focus on the walking first. We have total number of 16 students that come through walking. 14 of them are males. How many of them are going to be females, right? So 14 plus what is going to be 16? It's just that simple. 14 plus x is going to be 16, and x is going to be 2. So 14 plus 2 is going to be 16. We now know the number of females that come to school by walking, okay? Similarly here, we have 12 males who come to school by other means. 12 males who come to school by other male students that come to school by other means. And total number of students that comes to school by other means is 21. So 12 plus what is going to be 21? It's a simple linear equation. 12 plus x is going to be 21. You can find the value of x, which is 9. So you can say 9. 9 female come to school by using other means. And one other simple thing is that total number of males is 65. Total number of students is 120. So the number of females is going to be x, right? So you can find that out. 65 plus x is going to be equal to 120. You can find the value of x, which is going to be 55. So total number of females is going to be 55. Add them all together. 22 plus 17 plus 14 plus 12 is going to be equal to 65. This is the number of this is the different mode of transportation that males use, and add all of them together, you will get the total number of males. This is all the different modes of transportation that female use. Add them all together, you will get this total 55. So let's just say this is x. X plus 20 plus 2 plus 9 is going to be equal to 55, just like we have it here, right? 22 plus 17 plus 14 plus 12 is going to be equal to 65. So now you have this equation. Again, a very simple linear equation. Just add them all together and subtract them from 55. You'll get the value of x, which is 24. Now, this is the only one left. I told you this is 17 plus 20. 17 plus 20 is 37. 14 plus 2 is 16. 22 plus 24 is going to be what? It's just simple maths. 46. Just like that. X is going to be equal to, let's just say this was x. X is going to be equal to 22 plus 24. And that is 46. Simple. Now the table is complete. All the information that we need is complete. The first question, how many females use public transport? You can see it's 24. That's simply your answer. Nothing more, nothing complicated. It's 24. Okay. Then we have, wait a second. Yeah. Wrote it here like this. The number of females that use public transport is going to be equal to 24. Then they're asking us, now this is where it gets a little troublesome. A pie chart is to be drawn. They are telling us to make a pie chart, show the data of the survey. The data is given to you and we're just going to make a pie chart. So for that, first of all, we need to have a table. Do we have the table? Yes, we have the table. So we're not going to bother making another table. Do we know the total? Yes, we know the total. It's given in the question and it's also written here as well. The total number of students is 120. This is the total number of students that come through public transport. This is the total number of students that use car. This is the total number of students that use walking. The total number of students that come through other means, and the total number of students itself. Okay? By adding all of them together, you will get this. By adding all of them together, you will get this. By adding all of the second row, you will get this. Okay? total number of males, total number of females, add them all together, you will again get this. Okay, so you can add these two together to get this, or you can add this entire row to get this as well. This is a very interesting table. You should be able to understand and analyze these kind of tables, right? Then you have angle for each of these sections, right? So we're gonna have how many slices in the pie chart? You first need to understand this. This is all total, so we're not gonna talk about them. We're not gonna talk about them, right? We're not gonna talk about these totals. We're not gonna talk about these totals. You can make two kinds of pie chart. One pie chart can include one of the pie charts that you can make is going to be of 4 segments. Okay, it may include all the students that come through public transport, and that is going to be equal to 46. All the students, and another slice of the pie chart, which is going to be all the students that come through car, which is going to be 37, and all the students that come through walking, which is going to be 16, and others that can come through other means, which is 21. So 21 divided by the total multiplied by 360. You can do that, okay? But I used a different method. I wanted a more precise pie chart. So what did I do? I selected this table. Yep, this is the public transport for males. Then this is going to be our one slice. Cars for males is going to be another slice. This is going to be another slice. This is going to be another slice. So we're going to have total 8 slices, okay? And 8 different angles we need to find. That's what I did here. Angle for males in public transport is going to be how much? How much is public transport for male? 22. 22 divided by the total is 120 multiplied by 360. You can find the angle. Again, angle for males in angles for males you did before. Now you're going to do angle for females in public transport. That's going to be 24 divided by 120 multiplied by 360. That's going to be the angle for females in public transport. Then angles for male in car, then angles for female in car, then angles for male in walking, then angles for female in walking, then angles for male using other means and females using other means. You do all these angles, you will get a total of 8 angles, and then you can just simply construct a pie chart like I did. Okay, I told you there's one more simpler and easier method. You can, instead of differentiating between male and female, you're just going to talk about the categories themselves. So instead of males and females, I'm just going to talk about students, and this is the students, right? So this is the total number of students that you public transport. So I'm going to take this as my data, and then I will have only 1, 2, 3, 4. I will have only 4 slices in my pie chart. Each slice will represent different mode of transportation. Okay, so the students that come through public transportation is 46. So the angle for public transportation is going to be 46 divided by 120 multiplied by 360. Then the students, regardless of male or female, the total number of students that come through car is 37. So 37 divided by 120 multiplied by 36. Walking is like walk. The students that come through walk is like 16 divided by 120 multiplied by 36. Then others is like 21 divided by 120 multiplied by 36. You can find their angles, and then you can just make a pie chart with just 4 slices. And the slice of each name is going to be public transport, car, walk, and others. Okay, instead of differentiating between male and female. I can also do that here by this graph as well. What if I just add these two together? I have these 2 slices right here attached. What if I just remove this line in between them? Then this whole area will give me the public transport. Okay, regardless of male or female, this whole area will give me public transport. This whole area is for cars. Okay, one piece is for males using car, and the other piece is for females using car. But if I just remove this difference between them, this line between them, then the whole section is going to be for cars. Okay, same goes for here. We have 2 slices for walking, one for female walking, one for male walking. If I just remove the line between them, this whole section will become simply for walking of students, regardless of male or female. And the same goes here as well. You can just remove the line in the middle. Then you will have 4 slices in the pie chart. Okay, I just wanted to point that out, that you can make this pie chart through 2 different ways, whichever is simpler to you. I just wanted to show more details, that's why I used this method. Okay, then question number 13, 18 or whatnot, we're gonna skip it. If you have any problems, you can note them down and ask me on Monday.